Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to define what a degree is and what a radian is, explain how they were used to measure angles, and show how their definitions determine the number of degrees and radians in a circle. Let's begin by looking at the definition of a degree. Angles, such as the one in this picture, are measured by determining the amount of rotation from the initial side to the terminal side. A degree is, and let's go ahead and let's fill this in, a degree is a unit used to measure angles. It's symbolized by a small raised circle. A circle contains 360 degrees. Notice right here where the degree symbol is placed. The rightmost part of a circle is 0 degrees. The top is 90 degrees. The leftmost side is 180 degrees. And the bottom is 270 degrees. If we continue on from 270 degrees, we get back to 0 degrees, which can also be written as 360 degrees. Let's now talk about an angle of 1 degree. An angle of 1 degree cuts an arc of 1 over 360 of a circle. We can show this graphically by labeling this angle as theta is equal to 1 degree and labeling the arc as 1 over 360 of a circle. We can now precisely define what 1 degree is. 1 degree is the measure of the angle whose corresponding arc in a circle is, and let's go ahead and write this down, 1 over 360 of the circumference of a circle. We'll now talk about the definition of a radian. A radian is also a unit used to measure angles. To understand more about what a radian is, let's look at this angle theta. The initial side of the angle is the radius of the circle, and let's go ahead and let's draw that in blue. In this picture, I've made angle theta so that the length of the corresponding arc is the same as the length of the radius. So let's also notate that in blue. We can think of the radius and the arc as a piece of string. So the length of the radius is the same as the length of the arc, so the arc is also the same piece of string. And we can label the piece of string as length is equal to r, and then we'll label the radius as r. When these two lengths are the same, we say that theta is equal to 1 radian. Let's summarize this in this diagram. So in this diagram, we have an angle, which we'll call theta. We have the radius, which we'll call r. And we'll say that theta is 1 radian, which means that the length of the arc is also r. And then for completeness, we'll also recognize that the terminal ray, because it's along a circle, the terminal ray is also equal to r. We can now write down the precise definition of a radian. 1 radian is the measure of the angle whose corresponding arc in a circle is equal to the radius of the circle. Let's now look at some other angles. In this first picture, which we'll label as 1, the piece of string we can call r, and then notice that the arc is 1, 2, 2 pieces of string. So we can call that length 2r, because each piece of string is equal to r. So that length is 2r. When the length of the arc is twice the length of the radius, we say that theta is equal to 2 radians. In the second picture, which we'll label 2, the length of the arc is pi, or 3.14. So let's go ahead and write that down. So it's pi, or approximately 3.14. So you can see we have our piece of string, which we'll call r, and then we have 1, 2, 3, approximately 3.14 pieces of string. We can now label the piece of string for the arc as length is equal to pi times r. When the length of the arc is pi times the length of the radius, we say that theta is pi radians, or approximately 3.14 radians. In this last picture, which we'll label as number 3, the length of the arc is 2 pi, or 6.28. Let's see how that happens. So this becomes 1, 2 pieces of string, 3, 4, 5, 6, 6.28, approximately 6.28 pieces of string. So this means that theta is equal to 2 pi radians. Let's now summarize all 4 of the angles we've just looked at. For a circle of radius r, if we have an arc length equal to r, then theta is equal to 1 radian. If we have an arc length equal to 2r, theta is 2 radians. Likewise, pi r, theta is equal to pi radians. And then 2 pi r, theta is equal to 2 pi. And notice that 2 pi r is the circumference of a circle. we can now say that the length of an arc is the number of radians times the radius. We can also think about that in terms of the number of radians. So we can say that the number of radians is the length of the arc that the angle cuts out divided by the radius. So that tells us the number of radians in a circle is the length of the arc, which is the circumference, 2 pi r, divided by the radius, which is r. So that gives us how we come up with 2 pi radians in a circle. At least a little bit different of an approach, kind of looking at the equation rather than a graph. Now we know what degrees in radians are, so we can determine the number of degrees in radians in a circle. We'll start with 0 degrees, and then up at the top, we have 90 degrees, or pi over 2 radians. On the left-hand side, we have 180 degrees, or pi radians. At the bottom of the circle, we have 270 degrees, or 3 pi over 2 radians. And if we continue, we end up at 0 degrees, or we can say it's 360 degrees, or 2 pi radians. We'll end by filling in some values that are used a lot in trigonometry. The first one is this one right here, where it's 30 degrees, or pi over 6 radians. The next one that we use a lot is 45 degrees, or pi over 4 radians. And the last one that we use a lot is 60 degrees, or pi over 3 radians. When you study the unit circle, you'll have to memorize all of these points. But these are kind of the basic ones that we can build upon in further videos.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.